Hello there, I am Mr. the Engineer.
In this video we are going to talk about how engineering works. We engineers aim to solve specific human problems by inventing or constructing something useful for the works of man. You can compare engineers to a scientist, both needs a strong knowledge of science and mathematics. To build something is a very valuable thing for us. Engineers think in systems, it is like we deconstruct things in our mind in order to construct something. The passion for innovation and invention are most of what we love to do. But in this topic we are going to focus more on what engineers do, so let's go right into it. Some people think that all engineering professionals have the same knowledge, but they actually differ a lot. Most of the engineers specialize on a specific field, or type of engineering. Each field in engineering had their own expertise of knowledge and experience. There are many branches of engineering. But most of those branches belong to one of the four main classes of engineering. So, what are the four main classes of engineering? First we have the civil engineering. So, who are the civil engineers? Civil engineers are the professionals who deals with the designing, construction, and maintenance of the physical environment. These work includes with large structures such as roads, bridges, dams, canals, airports, sewerage systems, pipelines, railways, and many more. Civil engineers use math and physics to make sure that their designs are appropriate, safe and strong. Many people think that civil engineers are science and math wizards, but this kind of profession also entails imagination and problem-solving skills. And during the designing process, civil engineers takes into consideration the building costs, government regulations, and geographical limitations. Other factors to consider are the ground conditions, materials used in construction. Also, solutions for underlying weather conditions in relevance to the structures used are taken into account. After a construction is complete, the civil engineer will be responsible for inspecting, repairing, and maintaining the structural conditions of the constructed site. The next main class of engineering is mechanical engineering. This class of engineering involves the creation of machinery, such as cars, aircrafts, ships, and even robots, and other more. Mechanical engineers combines physics and mathematics principles together with material science in order to create, analyze, manufacture, and maintain the mechanical systems. Mechanical engineers are also responsible in the maintenance of the engines of cars, ships and aircrafts. They may overhaul some parts of the engine in order to repair it, or to replace it with a new part in cases of defects. Mechanical engineers simply keeps or make things moving. Like many other engineers, mechanical engineers use computer-aided design in making models. This is to further understand and simulate some analysis governing about the factors of how things work and react, in order to come up with the desired result. Now, let's go to our third main class of engineering. We have electrical engineering, in which they design, manufacture electrical systems or devices from the tiny components such as a microprocessor chips up to the biggest part, such as a heavy-duty machinery that are used to generate electricity. Electric engineers work in fields including the computer industry, automotive industry, and telecommunications. Understanding math and physics is essential for electrical engineers. On to the fourth main class of engineering. Chemical engineering. Chemical engineers apply the principles of chemistry, biology, physics, and mathematics, in order to solve problems that involve on the production or the use of chemicals, fuel, food and drugs and many more. Basically, chemical engineers test their findings and undergoes extensive analysis of their experiment in order to get the desired outcome. Now that you know the four main classes of engineering, let us now talk about the steps which involves how engineering works. All types of engineers follow the same basic step in solving a problem. This would involve a series of steps that are repeated over and over until a design or model has been proven, tested and/or improved. There are 6 steps in which they follow until they arrive to a solution and result. The first step is to state the problem. What are the possible problems that needs to be solved? And then, find out more extensive details and considerations as to what more can be questioned. For example, the problem may be is how to cross a river from one place to another place. Then possible questions in mind may arise, such as: how many persons need to travel and how often? Is there any access to any roads in the area? How deep and wide is the river? What long-term solution can be done to solve this? And the list of questions and considerations goes on. The second step is imagine. In this step, a wide imagination is needed. Here the possible solutions for the problem is determined. If we go back to the problem, we think of how are we gonna able to cross the other side of the river. And the possible solution might be building a bridge, or use a boat or ferry cars. Also considerations are made of what drawbacks might be encountered, the cost of each idea, and what is the best solution to answer the problem. The next step is to plan. In order to make those imaginations into reality, there is a need to design a plan. Think of it after the thorough and deep-seated thought for a possible solution. Let's just say, with all the considerations taken into account, such as the accessibility, cost of each solutions, and the long-term effect. You have decided to stick into one solution, which is the most effective and practical. And in our sample scenario, it is none other than building a bridge. So what do we plan? In the planning stages, a plan is to be designed and decided. Part of the plan is the sketch and design of the bridge. How large will it be? How will it be supported? And what materials will be used to build the bridge? Also, the effects of stress and environmental factors are to be considered, such as the weather. The fourth step is to have a model. On this step, a model of the bridge design is being studied. Engineers use a computer-aided design in order to actuate what could possibly result if a certain structured part of the plan is made on the certain area of the development process. Next we have the fifth step, test and improve. Once you already have a model, you will need to test it out and do certain simulations on things that may arise if such things won't be addressed or taken into account. There will be many cycles of testing in order to ensure that through model testing the desired result had been met. And lastly, the sixth and final step is to share. Yes, share. Once you have gathered all the necessary inputs after an extensive test of your model, the results must be shared to the client, who will then decide if he wanted to go and follow the proposed solution. If the client then decides to go ahead with the proposed plan, then everything is set for the project to start. Let's take a short review of what we have discussed. First, we identified that there are different branches of engineering, and that among all those branches are deeply rooted in four main classes. We have the civil engineering, mechanical engineering, electrical engineering, and the chemical engineering. And on those engineering classes comes into one common understanding or design process on how to solve a problem. First step is state the problem and know what are those sub-problems to that big problem. Second is imagine, and think a solution for those problem. Third is to have a plan with the solutions that you have for the problem. Then we have the fourth step, which is to have a model for the solution that you came up. In this step you create a simulation model and connect other things that may affect the model. On to the fifth step. After having a model, we need to test it and look for further improvement. This is where the simulation happens in order to attest considerable effects from the environment, such as the temperature, natural phenomena, structural designs, and so on and so forth. And lastly, the sixth step. Share all the gathered ideas and results from the test to your client, so that he or she can decide if they approved the proposed solution of their problem or not. There you have it, folks. You have just witnessed a glimpse of the world of engineering. How it works comes in so many decision-making and deep understanding, and most especially identifying considerable principles to every aspects of their work. You may be thinking that learning engineering is only limited to people who are professionals. But know this, by aspect in life we are all engineers. Engineers of our own self, who visualize and think and respond according to our logical comprehension. You are an engineer by nature, you mold yourself of what you want it to be and what you can become. Live life and think big. Hello, you have just gained an insight about engineering. Hope that you have learned a lot. If this video helped you, please give it a thumbs up, and please share this video to your friends to let them know what you have learned, and also please don't forget to subscribe, and hit that notification bell to be updated for more of Mr. The informative contents and other more amazing things to explore with.